Hey, thanks for joining us on Math Extra. I'm Rob Leichner, and if I've said it once, I've said it a million times. I'm a math person. Still a math person who needs a haircut, even worse this week. And because math is everywhere you go and in everything you do, we are all math people. So let's get started, 7th graders. Let's do this. Let's do the math on Math Extra. Hey 7th graders, today we're talking about scale factor. Now scale factor is going to help us determine how big or small something really is. Now what does that mean, how big something really is? So a lot of times when we're looking at something, we see it based on a representation. We see it either smaller than it really is or bigger than it really is. And we need to tell, using math and using proportions, how we can relate the picture or what we see to the actual thing. So here you see a map of North Carolina. North Carolina, you know, is way, 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 way bigger than this little, what, it's 9 inches or so that you can see on the map. So we need a way to figure out how big North Carolina really is, even though it's only about 9 inches or about maybe 25 centimeters on this map. Now the way we're going to do that is through something called scale factor. Now when you look at a map, a lot of times what you'll see is a little key, and it's got like maybe an inch or two, and it'll say 1 inch equals a certain number of miles. Let's take a look at the map. We have one of those on ours. So the scale of this map is 1 centimeter equals 25 miles. And if we want to know how far it is from Raleigh to Charlotte, because one of these days we'll be able to travel again, it's 1, 2, 3, 4, 5, just about 6 centimeters. Now every centimeter is 25 miles. So that's 25 miles, that's 25 miles, that's 25 miles, 25, 25, and 25. So now let's look at the scale factor mathematically. We looked at it visually. Math-wise, it's going to look a lot like proportions, which we did last week. But there's a very important difference, which I'm going to show you. Let's take a look. So here we have our table. Just like last week, we know 1 centimeter is 25 miles. We want to know 6 centimeters. So we can just count up, but we're going to try something even a little different. We know that it's proportional. For every centimeter, it's 25 miles. So for example, 2 would be 50. If we want to multiply 1 times what equals 6? Everybody, tough question. 1 times what equals 6? 6! Now we need to know 25 times 6. So, and that's going to tell us how many miles. 25 times 6? Anybody? Anybody? Ready for another mental math trick? 25 times 2 is 50. 2 times 3 is 6. So 50 times 3, it's 150. If we break up our numbers, a lot of times it's a lot easier. 25 times 6 is the same as 25 times 2 times 3, 150. So it's 150 miles about from Charlotte to Raleigh. Now what's interesting, if you go to Google Maps or MapQuest or even your GPS, it's not actually going to say 150 miles from Charlotte to Raleigh. It actually says something closer to 167. But that's because the roads don't go in a straight line. Remember, the shortest distance between any 2 points is that straight line. And if you take a straight line from Charlotte to Raleigh, the saying is as the crow flies, or as a plane would fly, it's about 150 miles. So now that we've seen how it looks in a table, we're going to see how it looks in a proportion. And now's where you're going to see the real difference between the proportions and the scale factor. So let's say our two cities were 17 centimeters apart. Remember, Charlotte and Raleigh were only 6 centimeters apart. Let's say 17 now. So here we have our one proportion, 1 centimeter for 25 miles. Now we're looking to see if it's 17 centimeters, how many miles, and for that I put an X. The scale factor is going to show the relationship between the two fractions. So last week with our proportion, we said, okay, 1 times 25 was 25. Every time we increase 1 centimeter, we increase 25 miles. Now we're going to say, if I multiply 1 times something to get 17, 1 times 17, and I multiply 25 times 17 to get the number of miles, 17 is our scale factor for those two fractions. That's the main difference with scale factor and proportions. Proportional reasoning talks about the two numbers within one fraction, within one ratio. Scale factor relates two separate fractions by whatever factor it multiplies. Because remember, factors always multiply. So if we're going back to solve our problem now, 1 times 17 is 17 centimeters. 25 times 17 is 425 miles. Ready to hear how I did that one? 17 times 25. 4 times 25 is 100. There are 4 4s in 17, so that's 400 plus one more, because it's 17, not 16, so 425. Isn't math great? Now, we're going to move on to something a little more real world. We're going to talk about making cookies for your whole school. So let's say there are 768 students and teachers in your school, and you can't wait to see them again in August. None of us can wait to see our schools again. But you're going to make all of them cookies to celebrate. Your recipe calls for 3 cups of flour and a ½ cup of sugar for 24 cookies. How much flour and sugar do you need for the whole school for 768 cookies? So for this, it's going to be a lot easier for us to just relate the two fractions using a scale factor than to figure out the proportion and have to know how much it goes up for every one cookie. You'll see why in a minute. It's going to make it a lot easier, and this is actually how chefs in restaurants figure out their proportions, because most recipes aren't written to feed a whole restaurant, but the cooks know math. So if we're looking at our first fraction, we have 3 cups of flour. I'm going to abbreviate cups with a C. For every 24 cookies. Now, we need to know how many cups for 768 cookies. So we need to figure out our scale factor. 24 times what equals 768? 24 times 32 equals 768. That's one you might want to use a calculator for. You don't have to use a calculator. 24 times 30 is 720. 24 times 3 is 72, so 24 times 30 is 720. Then 48 more, that's 2 more 24s, so it's 32. But calculators are okay too. That's why God invented them. Now back to the top here, 24 times 32 is 768, so 3 times 32 is 96 cups of flour. Now we're thinking about the sugar. I'm going to give you a minute to try this. Set up your fraction and try to figure out what are we going to multiply to get the total number of cups of sugar we're going to need. Take a second. Take a second. Take a minute. And I think a minute is just about up. Well, maybe not really, but let's move on. So we've got our same scale factor. We've got 3 cups of flour for 24 cookies. I'm sorry. Another thing that's very important, especially if you're the teacher doing this live, is making sure that you get your units right. So we're talking about 1/2 cups of sugar to 24 cookies. Now we still need 768 total cookies, and we need to know how many cups of sugar. 24 times 32 is still 768. 1/2 times 32 is 16 cups of sugar. So I hope that makes sense with scale factor to show how the 2 fractions relate to each other. Last time with proportions, we talked about how the numbers within 1 fraction or 1 ratio related. This time, we're talking about how the 2 fractions relate and how we can figure out those missing values. It's very, very important, and it's also going to help us lead into slope in 8th grade and a lot more things as you go into high school. For me, teaching math is really fun when I get to hear from a student and help them solve a problem. So this is my favorite part of the show, when we hear from our caller of the day. Hello?
Hello?
Hi, what's your name?
Frank,
Frank, thanks so much for calling in. What school do you go to?
Northeast Middle School.
Northeast Middle, awesome school. Who's your teacher over there?
Miss Gennaro.
Oh, Miss Gennaro, she's wonderful too. I guess all of our teachers in CMS are wonderful though. So what's your question?
How can scale factor be used in the real world for things like construction?
How can scale factor be used for things like construction? That's a great question, because that's actually one of the main ways in the real world that scale factor is used. So let's say they're building a really, really, really tall building. Let's see. Frank, can you give me a really big number?
200.
200, perfect. Let's say they're trying to build a building that's 200 feet tall. They can't actually draw out plans for a 200-foot building. It wouldn't fit on a piece of paper, would it?
Mm-hmm.
So let's say we're going to draw out some plans, and we'll say every 1 inch equals 20 feet. So every 1 inch on our plans equals 20 feet of our building. Now, Frank, if our building is 200 feet tall and 1 inch equals 20 feet, can you figure out how many inches tall our drawing is going to be?
Let me think.
Yeah, think about it. That's a pretty tough one. One inch for 20 feet, and we want 200 feet. How many inches?
I'm gonna say 10.
Exactly, look at you go. 10 inches. Now, let's take a look at what it looks like with scale factor. So if we set up our fractions again, we have 1 inch for 20 feet. We want to know how many inches for 200 feet. So 20 times 10 was 200. 1 times 10 is our 10 inches. Now, when we're making our plans for our building, we can't just do the whole height of the building. We have to do all the little windows. We have to do the door to get in the building. We have to do all the little trees outside the building. I'm going to try to draw them. I'm not the best artist, but see, look, there's our building. Every one of those little things on our picture has to fit that same scale factor, or else the building's going to fall over, because we won't have the door in the right place. We won't have the windows in the right place. So it's very, very important that we understand scale factor when we're making out plans for construction, or plans for anything, honestly. Does that make sense, Frank?
Yes, sir.
Awesome. Thank you so much for calling in.
Yeah, no problem.
What are you looking forward to most about getting back to school?
Just to learn, just see my friends, stuff, and yeah.
Awesome. Same for me. I'm really looking forward to, well, teaching instead of learning, but then also seeing all my friends too. So thanks so much for calling in. And stay safe. That's it for today's 7th grade lesson. But coming up next, Mr. O'Neill has something special for our 8th graders. Thanks to all my 7th graders out there. Great job with scale factor, and remember, we're all math people. Stay safe, and I'll see you soon.